Hello and welcome to another video. What we will be doing today is we are going to find the specific latent heat of fusion for ice using an experimental method. I'm showing you this video because unfortunately, because of the pandemic, you are not able to do this yourself. So I'm gonna show you how to do this. All you have to do today is record your data. We have here some ice in a container. We have a multimeter. This time it's serving as an ammeter, as you can see from the connection. We have a weighing scale and we have a small container here. We also have a stopwatch and a power supply. This power supply is set to give a constant output of 1 amp for current. We will measure the voltage that it outputs later as it gives the 1 amp. So we can calculate how much power it outputs. Let's turn on the weighing scale. So now it weighs 0 grams. We will record this later, 28.5 grams for the empty container. What you need to record later is the mass at a certain time. This weighing scale turns off every minute or so. I'm gonna turn it off, turn it back on. At around 45 seconds for each trial, I'm gonna turn it off, turn it back on. Take about 3 seconds, then put this here so we can see the mass when the time is. So I'm gonna put the stopwatch here. Okay, we're gonna do 2 parts. One is with the power supply off. You'll see how much ice is melting, so something like that. We'll do that for 3 minutes, and then we'll do the other one for 5 minutes with the power supply on. So remember, initially 28.5 grams. I'm gonna start the stopwatch in. Okay, I'm gonna put this here and I'm gonna start the stopwatch the moment I have this on. Starting. Oops, let's do that again. Starting. Okay, I'm gonna turn this off first. Alright, and then we'll put this here so you can see the stopwatch. Stopwatch here so you can see it better. While waiting, I will do something to make this look better. 40 seconds in and I'm turning on the weighing scale. 45 seconds in, I'm turning on the weighing scale. I'm gonna put this on and I'm gonna put it up just to see how much it weighs now. Oops. Alright, there we go. You should have seen that. Okay, we'll turn it back off. Wait for another minute or so. What I'm doing here is I'm just letting the water drain so that I know how much ice melts without. So I know how much ice melts. So that I know how much ice is melting with the power supply off. So the heater is turned off. And another thing here. Make this better even. There we go. Alright, turning back the weighing scale, putting this back on, and again lifting this away. Alright, we have 54. We're at 5 seconds to go. Alright, turning it back off. Alright, I'm gonna try to avoid putting this on like this so that I avoid shaking it too much, because what could happen is some ice could fall. But the reason why ice is falling is because the hole here is not really covered. It's still a big hole. You can't really see it here. So here, this hole here is really big and there's no cover like a cloth or whatever. And as you can see, I I'm gonna account for that one drop that fell on the stopwatch. I'm gonna put it in. I'm doing that. Okay, turning back on. We're almost at 3 minutes. Alright, let's see the wait again. Let's wait until it gets to 3 minutes. Five, 4, 3, 2, 1. 3 minutes. Alright, turning it back off and stopping the stopwatch. Now, your task later is to do this every 30 seconds, is to record every 30 seconds. Okay? Okay, I'm gonna reset the stopwatch. To make this fair, what I'll do now is I'm gonna turn on the power supply. I'm gonna let some ice melt for a while, and I'm gonna get rid of that melting water from there. Okay? Give it around 15 seconds. Okay, that should be good enough. Some water must have melted already. Let's weigh the empty beaker or the empty container. So let's start. Currently, our container weighs that much, and I'm gonna put the ammeter's turned on. It's recording 1 amp. I think you can see it here. The ice is dripping at a faster rate. So this is what we'll do. We're gonna start now. Okay, there. So again, the current is still 1 amp. We will record the voltage later because again, I've set this so that the current is constant at 1 amp. Alright, 40 seconds in, we're turning this on. Let's see what the wait is. We'll wait until 1 minute. 4, 3, 2, 1. Alright, there's a recording. Okay, let's put it off, turn it off, and wait for the next round. We'll do this for 5 minutes. All right. Let's turn it on again. Let's turn the weighing scale on again. Right now, that's how much it's recording, and if it's not obvious, it's not obvious on the video. I can tell you this much: the dripping's gonna be stronger. Oops, 57, 58. Oops, some ice fell. Well, that's fine. All right, we'll just record that either way. Okay. Off, and taking it off, turning it off, waiting another minute. Okay, turning the weighing scale back on. Okay, and putting back container. Alright, I still have it on. Let's see if it drips. Alright, we got the recording there. We got the recording there. Okay, turn it back off. Another 2 minutes. Current is really constant, holding constant at 1 amp. Now, I'm using a power supply here with a constant current feature, the constant current feature, because it makes it easier for us to calculate power, right? Because in order for the constant current to be maintained, and we have a constant resistance, that means the voltage will be constant as well. Anyway, here we go. for 4 minutes. Almost there. 5, 4, 3, 2, 1. Okay. Taking it off. Let's just wait for the final minute. Okay, let's turn back the weighing scale. Let's put the weighing scale back on and put the container back on as well. Go. Alright, that's our final data point. We will be, again, your task is to analyze the two sets of data. One is for this on, and one for the power supply on, and one for the power supply off. Okay. I'm gonna measure the voltage across the resistor with the ice on it, so everything else being the same, but instead of being connected as an ammeter, my meter is now connected as a voltmeter. Still at 1 amp, but now we are at 1.2 volts. Again, let me just show you the voltmeter now. It's at 1.2 volts at this setting, 1 amp. So again, the voltage is 1.2 volts at 1 amp. 1.02 volts at 1 amp.